Hey everyone, and welcome. Today we're digging into a really fascinating piece of source material called Fortress or Paper House, an architectural security autopsy. We've got a lot of ground to cover, so let's just jump right in. I mean, every single day it feels like we're just bombarded by terrifying headlines, right? We read about multi-billion-dollar banks exposing millions of sensitive records, government infrastructures completely paralyzed by ransomware, just massive global systems brought to their knees. And it brings up this wild paradox in the research. Why on earth do these global financial institutions, organizations spending absolute fortunes on custom code and hardware firewalls, suffer the exact same catastrophic fate as, say, a hobbyist's WordPress blog cobbled together over a weekend? How does that even happen? Well, to understand why these systems fail so spectacularly, we actually have to stop looking at the firewalls and start looking at the very foundation of how these software architectures are built in the first place. To really ground this engineering theory in reality, let's look at a quick timeline of catastrophe. Think back to 2017. The Equifax breach exposed 147 million highly sensitive records. 147 million. And that was all thanks to a systematic infiltration right through an outdated legacy framework. Now compare that to a typical WordPress crisis, where a wave of unexpected zero-day bugs and a simple page builder plugin can lead to hundreds of thousands of sites being defaced in literally a 24-hour window. But here's the kicker. Contrast both of those disasters with Amazon during peak Prime Day. They are handling tens of millions of concurrent requests during these massive global sales events, and they do it with zero downtime, zero data leakage. So what exactly is Amazon doing that the others aren't? Well, the answer comes down to a core structural flaw shared by both WordPress and that antiquated corporate software. They are both built on what engineers call a monolithic architecture. Basically, in these systems, the front end that you and I see, the back end's logic doing all the heavy lifting, and the database actually storing the information, they are all inextricably tangled together on a single shared server. It's a giant all-in-one package. And as you'll see, that creates a massive singular point of failure. And it turns out there are two main flavors of this monolithic disaster. First, you have WordPress, which is kind of like the Frankenstein of the web. You have businesses trying to mutate a simple blogging platform into a complex e-commerce system by sewing together dozens of random third-party plugins. The terrifying part? If just one of those unvetted plugins has a tiny flaw, a hacker instantly gets root access to your entire server. Game over. Then, on the flip side, you have legacy banking systems. These act more like fragile icebergs. They aren't relying on plugins. Instead, they're built on ancient languages like COBOL or old-school Java. Over decades, hundreds of different developers have blindly patched this massive block of custom code, creating an entangled mess we call spaghetti code. It looks totally imposing above the surface, but underneath, the logic is thoroughly rotted and incredibly brittle. So how are the modern tech titans avoiding this trap? The source material points to a brilliant antidote, and it's called microservices architecture. Instead of one giant tangled block of code, the system is completely shattered into dozens or even hundreds of tiny independent modules. And every single module is strictly responsible for one task and one task only. So, for example, you might have one isolated service exclusively for product search, an entirely separate one just for the shopping cart, and another purely for the payment gateway. So, the absolutely crucial point here is this concept of containment. Because these separate microservices have absolutely zero direct access to each other's databases, they only communicate through strictly vetted APIs. You can think of them like highly secure digital messengers just passing notes back and forth. If a hacker manages to find a loophole and breach, say, the user reviews module, well, their access stops right there. They are physically and logically trapped inside that specific module. They literally cannot pivot to steal your main payment database. It is the exact opposite of that monolithic structure we talked about, where one bad plugin brings down the whole house. But the evolution doesn't stop there. The next leap is pretty mind-bending, because it actually removes the target entirely. See, traditional servers leave their processing engines and databases totally exposed, right out there at the edge of the network. But with modern serverless and headless architecture, the whole concept of a server is redefined. The front end is pre-rendered as simple, static files distributed globally. So when hackers launch an attack, they are essentially throwing punches at a blank wall. It's just a static HTML file. There's no processing engine, there's no database residing there to hack. The actual backend logic is completely invisible, locked away behind proprietary cloud firewalls that only spin up for a fraction of a millisecond when needed. So the attack surface? It's effectively reduced to zero. But look, architecture isn't just about theory. It completely dictates the daily lives of the engineers actually running it. And operating a monolithic system, it is like operating in hell. If you manage a WordPress site, just clicking update is terrifying because a random plugin conflict could instantly trigger the white screen of death. But if you refuse to update, automated hacker bots are going to exploit you by tomorrow morning. And in legacy banking, oh, it's even worse. Modifying just one line of spaghetti code to add, say, a simple input field might accidentally crash the bank's entire core check clearing subroutine. Because of that fear, minor changes require months, literally months of agonizing QA testing. And deploying new code means forcing the entire bank offline at 2 a.m. on a Sunday. It is just a relentless, stressful workflow for engineers trying to keep the lights on. Now flip the script to what the source calls the microservices utopia. This is driven by automated continuous deployment. Imagine this scenario. Step 1. The search team deploys a brand new feature seamlessly. Step 2. The live system doesn't even blink, handling massive Black Friday traffic at the exact same time. Step 3. The payment team remains entirely oblivious to the search update because their systems are totally isolated. And Step 4. The end user experiences zero disruption or downtime. It's a beautiful thing. And this brilliantly illustrates exactly why decoupled architectures can scale so effortlessly and safely. And the data really proves these theories when you look at the unforgiving benchmarks in the report. Let's look at a simulated stress test of 10,000 concurrent users. A standard WordPress server? It just completely crashes under the weight. A legacy bank cluster survives, sure, but it suffers severe 10-second latency, which is an eternity online. The serverless model, though, it effortlessly autoscales and responds in under 200 milliseconds. What about a simulated SQL injection attack? WordPress is immediately compromised via its plugins. The bank relies on hardware to block it at the edge, but it's still highly vulnerable internally. But for the serverless architecture, an SQL injection is literally impossible. Why? Because the front end has absolutely no direct database connection. And finally, against a massive DDoS attack, WordPress is offline in minutes. The modern cloud architecture? It simply absorbs and disperses that massive traffic spike across intelligent global networks. So, you gotta ask, if modern architecture is so demonstrably superior, why isn't every single organization immediately migrating? Well, it usually comes down to a fatal psychological barrier: management's paralyzing fear of risk. It's a real dilemma. On one hand, executives are terrified of migrating because transitioning multi-terabyte databases threatens critical downtime. Plus, it requires astronomical capital costs, elite engineering talent, and let's face it, employees will fiercely resist learning new digital interfaces. But on the flip side, the risks of sitting still are arguably much worse. If an enterprise chooses not to migrate, their technical debt explodes until the legacy code becomes entirely incomprehensible. A catastrophic data breach becomes a matter of when, not if. And ultimately, it just leads to total market irrelevance as agile, modern startups run absolute circles around that decaying infrastructure. Let's shift gears a bit and see how this plays into the realities of modern cyber warfare. Because honestly, hackers rarely bother attacking a massive corporate firewall directly anymore. Instead, they use a surprisingly simple backdoor: the supply chain attack. Take the famous Target breach, for example. Cybercriminals didn't actually attack the retailer directly. Instead, they compromised a third-party HVAC contractor that had weak security. They exploited that vendor's vulnerable software, stole their authorized VPN access, and literally just walked right through the front door of Target's multi-million-dollar primary firewall. It's wild, but it happens all the time. And that brings us to a really harsh reality check. You can build the most invisible, decoupled, serverless titanium fortress in the digital world, but it is entirely useless if the person holding the keys just hands them over. The human element remains the absolute weakest link in the chain. Social engineering, highly targeted spear-phishing emails, or, a C-level executive using a super weak password can bypass millions of dollars of architectural engineering in a fraction of a second. Cybersecurity is a chain, and at the end of the day, it's only as strong as the human being operating it. So the brutal truth we've uncovered from the data today is that while tech titans are guaranteeing security through isolated microservices, countless enterprises out there are still clinging to fossilized code, mostly just out of fear. Relying on generic, monolithic platforms or decaying legacy code is a gamble that you are mathematically destined to lose eventually. Migrating to modern, serverless architecture isn't just a nice little IT upgrade anymore, it is the absolute prerequisite for corporate survival. So as cyber warfare evolves every single day, it leaves us with one final provocative question from this analysis. Is your enterprise still running on a decaying paper house?